The cone is what we get when we have a circular base and an apex, and we treat it very similar to a triangle, or not a triangle, a pyramid. So we draw from each, or we extend the side from each part of the base to the apex, and so we end up with a shape like this. It's a cone. With a cone, we can describe things like the lateral surface area again. And I'm going to scratch out the ones using diameter again, because I don't use those. I use these ones right here. Those are the ones I recommend, because why learn 3 different formulas when one will suffice? We talk about the height of the cone. Again, this is measured at a 90-degree angle to the or it's measured in orthogonal, actually, is what it's called, to the base. And we can also talk about the slant height, which is measured along the lateral, along the side, between the apex and a point on the circle. Alright, if we want to find the lateral surface area, total surface area, and volume of this cone, first off, our base is down here. So that means the radius of the base is 10 inches. This one right here is S, and this one would be height. Once we have those, it's just a matter of kind of plugging stuff in. The lateral surface area is pi times r times s. That is, well, pi times the radius, which was 10, times the slant height, which is 18. So, let's see. 10 times 18 times pi gives us 565.5. Those are in inches, so this would be in square inches. That's a lateral surface area. The total surface area, just like when we were talking about pyramids, you take your lateral surface area, you only have the one base, so you'd add that base on there. So you take, not L. S is equal to L plus A. Your lateral surface area, well, it's a circle, and with a radius of 10, so that means our laterals, or not lateral, the base surface area, saying the wrong words. Alright, so it is pi r squared. So this would be, in this case, pi times 100, so 314.159. So we end up getting, for the total surface area, this would be the 565.5 plus 314.14159 whatever. Add those together, we get approximately, let's call this 879.7, because this rounding that up to the rounding this to the tenths place, 879.7, we'll call it. That would be our total surface area. And for our volume, I'll use the formula that we're given for the volume right there. Volume is 1/3 pi r squared h. So if you're paying attention, you may notice that these formulas are very similar to the formulas for those of the triangle. The lateral surface area, well, this is kind of, if you include a factor of 2 and 1/2 in there, 2 pi r is the diameter, or yeah, the circumference rather, and 1/2 perimeter times the slant height was the lateral surface area of a pyramid. So the 1/2 times 2 pi r, well, the 1/2 times 2 cancel out. We're just left with pi r s. As far as the volume, we saw with the pyramid, it was 1/3 times the perimeter, 1/3 times the area of the base times the height. This one, this pi r squared, that's the area of the base right there, and you can see it's the exact same. So just like with there's parallels between a cylinder and a right prism, the cylinder and a prism. Those same parallels exist between cones and pyramids. The formulas are essentially the same thing. You just call them slightly different things. So in any case, 1/3 pi r squared, well, that's 1/3 times pi times 10 squared times the height of 15. So this gives us 1/3 times pi times 100, that's 10 squared, times 15, which gives us 1,570.8, I'll call it. and this would be measured in cubic inches since it's a volume.